Homework 10, Quadratic Functions, Video 4. Sketching the graph of a quadratic function. This will actually be spread over 2 videos because we're going to graph the 2 quadratic functions that we've worked with so far. But for each one of them, we're going to do the same 4 steps. Step number 1, find the vertex. Well, we already found the vertex on the previous 2 functions, so we can check that off. Step number 2, find the axis of symmetry. It's actually a really easy thing to do. The hardest part about it is answering it in the way the homework wants you to, and I'll show you how. Step 3, find the Y-intercept and its reflection across the axis of symmetry. I'll show you what that means in just a moment. And then step 4, find the X-intercepts if they exist. Now what do I mean by if they exist? Well, the X-intercepts are where a graph crosses the x-axis. Because a parabola changes directions, it's possible it could change directions before it crosses the x-axis. It's also possible for it to cross the x-axis twice. 1, 2. And it's also possible for it to have exactly one x-intercept, where it touches the x-axis and turns around. And of course, all 3 of those cases apply to an upside-down parabola as well. So it is possible for a parabola to not have any x-intercepts. We'll talk about how to find them in a moment. So let's take a look at the first example. F of x equals x squared minus 7x plus 10. Starting with the vertex. Well, we already found the vertex in the previous video. Actually, it was the video prior to that, video number 2 in this series. And I believe the vertex was 7/2, comma, negative 9/4. Yes, because I was saying don't use 3.5, but if you did, you would get negative 2.25. So how do you describe the axis of symmetry, or what does that even mean? Well, in order to explain the axis of symmetry, let's go ahead and start graphing this. Because these are fractions, I am going to draw my x and y axis in halves and quarters, well, roughly speaking. But I want this to look pretty good, so let's do this. Let's draw a pretty good x and y axis. And I'm going to mark up the x-axis in increments of 2 inches. So there's 1, 2, 3, 4, 5, 6. And let's go backwards. 1, 2, 3, 4, 5, and 6. So that's actually 1 foot on each side. And I'm going to put a dot in the middle of each just so I can find the halves pretty easy. Actually, I only need to find 7 halves, and that's over here. And on the y-axis, I'm going to mark up increments in every 2 inches as well, so that we're consistent. 3, 4, 5, 6. Don't think I'll need to go that high. 1, 2, 3, 4, 5, 6. But on the y-axis, I'm going to need to find quarters, and specifically negative 9/4. So 1, 2, 3, 4, 5, 6, 7, 8. So that'll be right about there. So I'll only split this 1 into quarters between negative 2 and negative 3 because that's the only one that I'll need. Okay. So let's start by plotting the vertex. The vertex is at 7/2. So 1, 2, 3, 4, 5, 6, 7, and then down negative 9/2, which is negative 2 and 1/4. So it's about here. By the way, this parabola will open up because the leading coefficient is 1, and more importantly, it's positive. So this graph's going to open that way. I don't need to worry about the graph being below it, so I will label the vertex below it, 7/2, comma, negative 9/4. The axis of symmetry is a line that drops right down the middle of the parabola. So I can draw a line straight down the middle. Now in the homework, if they ask you to sketch the axis of symmetry, to draw the axis of symmetry, they may ask you to draw it as a dashed line. So in the homework, if they ask you to do that and you don't, then it's going to say it's wrong. Now, how do you draw the axis of symmetry in the homework? Well, you would click the line button and then just click any 2 points. You can click the vertex at any point above or below it. But what is the equation of that? Well, it's a vertical line, and as a vertical line, its equation is x equals a number. And because it goes through the vertex, the equation of this axis of symmetry is x equals 7/2. But generically, to describe the axis of symmetry, you can always just say x equals, and then just list the x coordinate of the vertex. So if your vertex was 1, 7, then the axis of symmetry would be x equals 1. All right, so our axis of symmetry is x equals 7/2. And now let's go find some intercepts, starting with the y-intercept. Now, finding the intercepts is going to be a recurring theme throughout the next few sections. So it's important to know how to find the y-intercept and the x-intercept in general. In general, you're a y-intercept if you are on the y-axis. And if you are on the y-axis, then your x must equal 0. In a function, the x is what you put in. So in order to find the y-intercept, all you have to do is calculate f of 0. Let's write that over here. For the y-intercept, you calculate f of 0. Always, 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 always. Well, putting 0 into this function is pretty easy. 0 squared minus 7 times 0 plus 10. Everything disappears except the 10. And of course, I don't have room up to put 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that sucks. So here's what I'm going to do. I'm going to relocate the x-axis. On a paper, I would just draw it taller or something. But I'm going to relocate the x-axis, which is going to relocate the vertex, but that's okay. Let's just reverse engineer it. If I want a y-intercept at 10, I need this to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So we're going to put the x-axis right through here. If I had thought about this a little bit more in advance, we would have avoided this problem. That's okay. It's all right. And this was marked every 2 inches, so there's 1, 2, 3.5, 4. And then this was marked every 2 inches, so I need to cut this into quarters. Sorry, hate to do damage control in the video, but we've gone too far into this video for me to pause and start over. So we'll just bear with it. So it's right about here. All right, so 7/2, comma, -9/4. All right, so let's pretend this is how it started the whole time. Now we can plot our y-intercept. It's way up here. Let's plot it in red. At 0, 10. I'll write the coordinates over here. Now, what I'm about to show you is that it's actually necessary, but I like it because it takes advantage and really illustrates what the axis of symmetry does. Every point on the left side of the axis of symmetry has a mirror image on the right, including the y-intercept. How do you find the mirror image? Well, it's easy. You ask yourself, how far from the axis is it? That's easy. It's 7/2 away. And then you go that distance to the right of the axis. So if I'm at 7/2 and I go another 7/2, that puts me at 14/2. 14/2 is better than a 7. It's a lot easier to explain when it's not a fraction, but we've come this far. 1, 2, 3, 4, 5, 6, barely made it into the window. So the mirror image of the y-intercept is 7.5 spaces to the right of the axis. And again, when it's whole numbers, it's a lot easier. You may or may not be able to see this ordered pair, but it is over 7 up 10. Let me just check real quick, I'm curious. I may move the camera, I may not. You can kind of barely see it, but let's just do that. There we go. There we go. At this point, we could probably draw our parabola. We know where the vertex is. We know it goes up and makes that shape. But let's go ahead and find the x-intercepts. Because this is also going to be a recurring theme throughout the next few homework sections. If you're an x-intercept, that means you're on the x-axis, which means your y-coordinate is equal to 0. In a function, the y is what comes out of the function. So in order to find the x-intercepts, generically, we need to solve f of x is equal to 0. So here, we need to solve x squared minus 7x plus 10 is equal to 0. By the way, when I created this function, I created it with the intent of it factoring, because I knew at this point factoring would be very convenient. It factors into x minus 2 and x minus 5. Think about it. If we set each factor equal to 0, x minus 2 equals 0 and x minus 5 equals 0, we get x equals 2 and x equals 5 as the location of the x-intercepts. 1, 2, 2, 3, 4, 5. There's no need to find the mirror image of the x-intercepts across the axis of symmetry. They are each other's mirror images. So now I can just kind of freehand it. You could also generate more dots by inserting more values, you know, old-fashioned graphing. But let's just kind of, that one's not bad. And now let's go for this guy. Huh, I've drawn a lot worse. In the homework, when they ask you to draw a parabola, they will ask you to do one of two things. Number one, click on 3 dots, because 3 dots uniquely defines a parabola. So you need to have 3 of them ready, vertex and some intercepts. On some graphs, however, they will ask you to click on the vertex and an intercept. In this case, I would have 3 to choose from. But by setting up the vertex, you're setting the axis of symmetry, and by clicking on any other point, like an intercept, its mirror image would help generate the 3 points necessary. A couple of things about this parabola before you look at the other one. In the homework, they are going to ask you to not only sketch the graph by clicking on the parabola tool, but they will also ask you what is the axis of symmetry. I don't think it asks you to draw it, but if it does, be very careful. Wants it to be drawn as a dotted line. But they'll also ask you what's the equation of the axis of symmetry, so just x equals whatever the x coordinate of the vertex is. But on some of the homework questions, they will also ask you the domain and range. This is not necessary to graph the parabola, it's just a follow-up question. Well, the domain's easy. This is a polynomial function. It has no issues. Its domain is all real numbers, negative infinity to infinity. For the range, bottom to top. Look at the lowest point. What is its y value? Negative 9/4. And it is included, and it goes up forever. So the domain is always going to be negative infinity to infinity, but the range won't be. If it's a parabola with a low point, a minimum, the range will start at the lowest y value and go up forever. But if it happens to be an upside down parabola, the range would start at negative infinity and come up to the highest y value, as we'll see in the next example.